Good day, students. This is School on Air. The topic I have in mathematics is integration, continuation of integration. In the last episode, I talked about integration, and today I'm talking more on integration. I mean deeper side of integration. Let me quickly do a recap of what I taught earlier on. In integration, I talked about definite introduction of integration. I talked about definite and indefinite integral, and I said something there which they are very vital to what I'm doing today. Now, in this question, this f prime of x, right, it means the y dx or the gradient of this function. F upon x is equal to this. Find f of x if the curve passes through this point. Now, it means that this, for you to find an equation here, you know, I said when I was doing the first in the last episode that when you have integrated, you have a constant c. When you see a equation like this, and the thing is that you find the equation at a particular point, it means that at the end of your calculation, you get the value of c, which will be part of your equation. Now, let us see the solution. And this solution, you know, I tell you that this one is equivalent to the y dx or the gradient of a particular function. Do we want to get the original function? Now, f of x, I integrated this function. So I have 6 raised to power 3. 6s raised to power 3 all over 3, which is equal to 2s raised to power 3 plus 10s raised to power 2 all over 2, equal to 5s raised to power 2 minus 7x plus c. Now, you know that this is the integration of this function. Now, at this point, minus 1, 5, it means that this value, a coordinate means x and y. So, that this value is the value of x, this value is the value of y. Now, you know, this one, this is y equal to this one. So this f of x is equal to 5, while all this s, their value is equal to minus 1. Now I put 5 here is equal to 2 minus 1 raised to power 3 plus 5 minus 1 raised to power 2 minus 7 bracket minus 1 plus c. I have 5 is equal to minus 2 plus 5 plus 7 plus c. Now c is equal to 5 minus 10. 5 minus 10. In this place, c is equal to minus 5. Now, when c is equal to minus 5, and you put the minus 5 inside the equation, you have 2s raised to power 3 plus 5s squared minus 7x minus 5. So that will be the final answer. This is another question. If u and v are two variables such that the u dv is equal to 4v minus 3 and u is equal to 5 when v is equal to 2. You know, in this place we are talking about u in respect to v. Now, we have the u dv is equal to 4v minus 3. When the u dv is equal to 4v minus 3, it means that u is, I will integrate this function, so it will be 4v squared minus 2 minus 3v plus c. I will have u is equal to 2v raised to 2v squared minus 3v plus c. You know, I have this u and v as the quantity, I have 5 comma 2. Now, when it means that when u is equal to 5, v is equal to 2. Now, I replace this u with 5, then v with 2. Then I have 5 is equal to 2 bracket 2 square minus 3 bracket 2 plus c. Now, in this case, my c is equal to 3. Now, this 3, you take it back to this equation A. So I have my u now will be equal to 2v squared minus 3v plus 3. You know, here I got my c is equal to 3. Now I have 2v squared minus 3v. Instead of plus c, I have 3 as my final answer. So this one is the equation. Now this is another question. A line passes through the point 5 and minus 2. This is a coordinate, and its gradient is equal to minus 3. Find the equation of the line. All this question I'm taking, the application question, is like what I've taught you in the first episode. We are applying it to a particular question. Now, this minus means that its gradient is minus 3. It means that the y dx is equal to minus 3. Now, the y dx, we can use m at times to represent the y dx. We normally use m as the y dx. You know, by the time you are finding m, when you have two coordinates and you want to find m, you want to find equation of a line. You have m is equal to y minus y1 all over x minus x1. This one is a formula. Now, when you have this coordinate 5 and minus 2, it means that this 5 is y1, this 5 is x1, and this minus 2 is y1. Now, when in this formula you see y minus y1 all over x minus x1. This formula is the formula of finding gradient, change in y over change in x. Now when I add this one, y minus 2 all over x minus 5, then I have y plus 2 all over x minus 5 is equal to minus 3. Remember, gradient is equal to minus 3. Now, so this one is equal to minus 2, then I cross multiply, then I get the equation minus 3x plus 15 is equal to y plus 2. Then I put it, I just collect the like times, I have y plus 3x minus 13 is equal to 0. So this is the equation of the line. Here's another question. A particle moves a straight line. Its velocity after 60 seconds is given by 36 minus 40. The distance of the particle from a fixed point on the line after t seconds in s meter and s is equal to 40. When t is equal to 1, find s in terms of t. In this place, when I was teaching you integration, I made mention of acceleration time, velocity time graph, velocity time graph, and displacement time graph. And if you look at this question, they are talking about the velocity here, and they want to find the s is the displacement. Now let me show you the solution. I have v from the question is equal to 36 minus 40. Then if you have x displacement in respect to time, when you have displacement, when you differentiate that, you get v. Now when you have v, you want to get s, you integrate v to get s. Now to get s here, I need to integrate this v. And for me to integrate this v, no, this v is velocity. When I integrate this v, I get s. So what is the integration of this function? The integration of this function is 36t minus 2t squared plus t plus c. Now in the equation is that when s is equal to 40 and t is equal to 1, what is the equation? When s is equal to 40, means that this s is equal to this equation, then I will replace this s, I put 40 there, then t is equal to 1, I remove this t, I put 1 there, so 36 I have 1 minus 2, 1 squared plus c. Then I get this equation, 40 is equal to 36 minus 2 plus c. So the answer is 40 is equal to 34 plus c. At the end, c is equal to 40 minus 34, which is equal to 6. Now when c is equal to 4, I just come here, I remove this c, I put 6 there, so I have this as my final answer. So displacement of distance is equal to 36t minus 2t squared plus 6. This is another question. A particle moves along a straight line in such a way that its acceleration after t seconds is 2t plus 1 centimeter per second square. If its velocity after t seconds is v centimeter per second, find v in terms of t, given that v is equal to 11 and t is equal to 2. In this case, we are given acceleration. Like what I said earlier, we have acceleration, velocity, and displacement. When you differentiate acceleration, you have velocity. Now we have acceleration, now we want to get the velocity. So when we integrate acceleration, we get velocity. Now that's why I have v is equal to integration of acceleration. So a is equal to 2t plus 1. So when I integrate this function, I get this. I get t squared plus t squared plus t plus c, which is the constant. Now we are given that v is equal to 11 when t is equal to 2. So it means that I can substitute 11 for this v and 2 for this t. Now I have 11 is equal to 2 squared plus 2 plus c. At the end, I have 11 plus c. 11 is equal to 6 plus c. C is equal to 11 minus 6, which is equal to 5. So c is equal to 5. Now the equation will be v is equal to t squared plus t plus 5. Here this c is what I got here, which is equal to 5. So I just remove c, I put 5 there. So this is the equation of the velocity. Now this is another question. A particle starting from rest at p moves along a straight line pq so that its acceleration after 6 seconds is 24t minus t squared meter per second square. Number 1, find when it returns to p and its velocity there. Let me say something about this concerning this question. If you read this question, a particle starting from rest at p, when a body starts from rest, or a body after a motion, the body comes to rest, it means that whether initial or final velocity is equal to 0. So when they say that this body, find when it returns to p, you know that when it comes to rest, it travels and comes back to p. And that is this question says that a particle starting from rest at p. So when it's starting from rest at p, when it comes back to p, it comes back to rest. Now to find to find the velocity here, we need to find the time at which you come to rest. I'm going to consider the velocity as 0 concerning this question. Then the second one, find the maximum displacement from P during this interval. The third question says what is the maximum velocity and its greatest speed during this interval. This is the solution. We are given A is equal to 24t minus 12t square. I said earlier on, we want to get velocity from acceleration. When we differentiate velocity with acceleration, the v dt is equal to acceleration. So when we integrate acceleration with respect to t, we get velocity. Now we integrate this function to get v. Now when we integrate this function, we have 12t squared minus 4t raised to power 3. Now when it reaches q, the final velocity is 0. I said that one earlier on, that because the body started from rest. So when the body started initial velocity is 0. When it comes to rest, the final velocity is equal to 0. Now in this case, velocity is equal to 0. Now our velocity is equal to 12, which is the integration of acceleration, is 12t squared minus 4t raised to power 3. Now when velocity is equal to 0, it means that this equation is equal to 0. So 12t squared minus 4t cubed is equal to 40 raised to power 3 is equal to 0. Then 40 is equal to 12t squared. In that place, we just mathematically t is equal to 3. We divide both sides by 4. Then t squared goes that place. T squared divided by t raised to power 3 is equal to t. So t is equal to 3. Now, if it gets to q at 3, it will return to p after 4 seconds. Now, this one is a logical aspect in this question. When the body is moving, from p to q, when you get to p, 3 seconds, you get to p at 3 seconds, that it will leave that point after that 3 seconds, coming back to p. So you get to p after 4 seconds. If you can't get it depends on the distance, but it can't leave a point at 3 seconds and get another point at 3 seconds. So logically, this body will get to p after 4 seconds. Therefore, it is to p after 4 seconds. We can't say precisely. Now, at the point of return, its velocity is equal to 12. We get this one as our velocity. We get our velocity as 12t squared minus 4t raised to power 3. Now, in this case, when after 4, that is after 4 seconds, it will get to that place. So that will be 12 bracket 4 raised to power 2 minus 4 bracket 4 raised to power 3. So that will give us 196 minus 1256. If you look at this answer, we get minus 64 meters per second. Why minus? We get minus because the body moves from P to Q, then returns to P. So it's like by the time a body is moving, it has positive velocity, but by the time it's coming back, we have negative velocity. That's why we have minus 64. As I said, that NB, the velocity is negative because the body returns, that it is moved in a backward direction to its previous movement. Now, the second part of this question, we want to calculate the displacement. Now, I said earlier that if you differentiate the velocity, you find the v dt. You have v in respect to t. If you differentiate the v dt, when you differentiate the s, when you have displacement in respect to time, when you differentiate downward, you have velocity. But when you integrate velocity, you have displacement. In this place, we get our velocity earlier. Now, to get the displacement, we need to integrate our velocity. Now, to integrate, in the previous solution I have 12t squared minus 4t raised to power 3. Now, when you integrate this function, like I'm integrating acceleration twice. For me to get this way, I need to integrate first, acceleration first, I get velocity. When I integrate velocity, I get displacement. Now, in this place, I get 4t cubed minus t4. At this juncture, I want to say something. Now, normally say when you integrate, you have c. That c is optional. Actually, as this type of question is concerned, that c is not very vital because there is no information that gives us what happened at the initial stage. Now, when we have t in this place, when t is equal to 3, then displacement is equal to 127. We just substitute 3 inside this equation. Then the third part of the question, I have at maximum, what is the maximum, the time as the maximum velocity? At the maximum velocity, acceleration is equal to 0. Now a is equal to 25t minus 12t square. When a is equal to 0, I have t is equal to 2. When I equal to 0, I have t is equal to 2. Then when t is equal to 2, then v, I just substitute 2, I substituted 2 in the equation for v, then I get v is equal to 16. So that's what happens at the maximum velocity. That's the velocity. Now in this another question, therefore the maximum velocity is equal to 60 meters per second. Then the greatest speed, they ask about greatest speed. How is it like speed and velocity? They can be used interchangeably. You know, velocity is a vector quantity, while speed is a scalar quantity. Now greatest speed is equal to maximum velocity. Therefore greatest speed is equal to 60 meters per second. I've talked about displacement, velocity, and acceleration. And I talked about I said something about velocity, acceleration, displacement, and velocity. V is equal to ds dt. That will refer to differentiation. Now when you have v is equal to ds dt, a is equal to dv dt. We want to have s, for example, now from v to s, when you differentiate the s, you get v. If you integrate v, you get s. That's what I write. If you integrate v, you get s. A is equal to dv dt. If you integrate a, you get v. So that's what I'm saying here. So all this method, you need to master all this one. When do I differentiate, when do I integrate to get velocity, to get acceleration, to get displacement? All these things are very important. Now I want you to do this assessment question. I have two assessment questions. The first one, a particle moves along a straight line in such a way that its velocity after t seconds is equal to 3t squared minus 4t plus 1 meter per second. The distance of the particle from the fixed point A in the line is s meters after t seconds, and s is 5 when t is equal to 2. Find the distance of the particle from A initially after 1 second, and the second one after 4 seconds. I want to know this question. Now I think I can go to the second question. Now this second question, find the area bounded by the curve y is equal to s squared minus 7s plus 10, the x-axis and the line x2, the x-axis and the line x2 and x equal to 5. Like this question is definite integral question. Like you have integral, you have 5 up and 2 down, then you have the equation. Just integrate. This one is an example of, it's an application question that has to do with definite integral. Now so when you have integral of 5, you have 2, you have this equation, integrate and get a definite answer for the question. So I appreciate your participation in this episode this day, and I know that going through what I've said and try to apply them to all these questions, you will get all of them and you're happy you do. Thank you very much. Happy viewing.